So today we're going to start Unit 3, which is all about exponential functions. And the first learning target is to be able to determine if a table, graph, and situation can be modeled with an exponential function, a linear function, or neither. So first, remember back to the linear functions, and we know that if a function is linear, then the change, like how the two columns are changing, has a constant difference. And difference implies subtraction or addition. Now, if a function is exponential, then the change, oops, that needs an E right there, then the change has a constant multiplier. I think that's how you spell multiplier. So, for example, let's take a look at some of these functions and see if we can find which ones are linear and which ones are exponential and what we mean by multiplier. So here, if we look at the x column, it's increasing by 1. And then over here, the y column is going up 3, up 3, up 3, up 3, up 3. So because we're adding 3 each time, from 4 to 7, we add 3. From 7 to 10, we add 3. Because we are adding 3, I'm going to put a plus in here, plus, 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 and plus. Because each of those are adding 3. I'll zoom in so you can see that better. And it's the same all the way down. We know that this is a linear function. So I'm going to write linear right there. Now let's look at this one. So this is going up 1. Now here it's going adding 2, adding 3, adding 4, adding 5, adding 6. So adding doesn't work. We know it's not linear. Now let's try multiplying. So to find a multiplier, just like if we weren't sure what to multiply by, we would take the 7, or to add by, we'd take the 7 and subtract 5. You take the one below minus the one above, and it would give you this 2. 7 minus 5 gives you the 2. 10 minus 7 gives you the 3. We can do that same thing, but instead of minusing, we're going to divide. So I'm going to use my calculator over here. And when I do that, I'm going to take the 7 and I'm going to divide it by the 5. So 7 divided by 5, and I get 1.4. So I'm going to times 1.4. That would be my multiplier. You could add 2 or you can multiply by 1.4 to get from 5 to 7. Now I'm going to find what the multiplier is from 7 to 10. So I'm going to take this one and I'm going to divide by the one above. So 10 divided by 7, and I get 1.43. That's the multiplier there. So it looks like this function is not linear because it doesn't have a constant adding and subtracting number, and it's not exponential because it doesn't have a constant multiplier we get by dividing. So I'm going to write neither. Now let's look over here. Going up 1. Now, from 1 to 2, it goes up 1. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. And 32 minus 16 is 16. So that doesn't work. So the adding, if I add, those are all pluses right there. Those don't work. So it's not linear, we know, because it doesn't have a constant adding change. Now let's try multiplying. So 2 divided by 1, to find the multiplier, you take the one below and you divide by the one above. So 2 divided by 1 is 2. So that has a multiplier of 2. 4 divided by 2 is 2. So that also has a multiplier of 2. 8 divided by 4 is 2. 16 divided by 8 is 2. And 32 divided by 16 is 2. So it's not linear because it doesn't have a constant adding and subtracting number. Sorry, but it is exponential because it does have a constant multiplier. So we are going to say that this function is exponential. Now let's look here. Here it has a constant change of 1. Now, from 243 to 81, I'm just going to look at this right now. I know it's not linear because if I look down here, I know to get from 9 to 3, you go down 6, and from 3 to 1, you go down 2. So I already know it's not linear. I can see that it's not a constant change, adding and subtracting wise. So I'm just going to go right to multiplying. So to find the multiplier, I'm going to take the number below, and I'm going to divide by the number above. So 81 divided by 243, and I get 1/3. That's my multiplier. 243 times 1/3 would give me 81. Now I'm going to find it here. So I'm going to take that and divide it by 81. So 27 divided by 81, and I get 1/3 again. So a multiplier of 1/3. Okay, from 27 to 9, that's going to be multiplying by 1/3, multiplying by 1/3, multiplying by 1/3. So because it has a constant multiplier the whole way down, this one is also exponential. Okay? To find out if these are exponential, we're just going to identify points. So it looks like this is a point, this is a point, this is a point, this is a point. So we have, if I make my table here, let's do that. Oh, sorry, you can't see. So I have all these points that I've marked that are like right at the integer values. And so my x and y value, I have -1, 1, 0, 2, 1, 4, 2, 1, 2, 3, 4, 5, 6, 7, 8, 2, 8. And then we'll see if it has a constant multiplier, just like we did above. So this is going up by 1, so we're good over there. Now here, 2 divided by 1 is 2, so a multiplier of 2. 4 divided by 2 is 2, so a multiplier of 2. 8 divided by 4 is 2, so that also has a multiplier of 2, so it is exponential. Never mind my little thing over there. Okay, now let's try this one. So it looks like we have a point right there, and right there, and right there, and right there. So that would be -2, 1, -1, 2, 0, 5 is that one right there, and then 1, 10 is that one. So now let's make sure that these are all a constant multiplier. So it's going up by 1 over here, and then from 2 divided by 1 has a multiplier of 2. 5 divided by 2 does not have a multiplier of 2. That would be 2.5. And then 10 divided by 5 is 2. So it looks like this is not an exponential function. Okay. And now if you're looking at a situation, down here, this last part, and deciding whether or not a situation is exponential, you can make a table to model the situation, then figure out the pattern of the table, just like in the above examples. So it says, on a countertop, there's 1 bacteria remaining after you chop up some raw chicken. Each hour, the amount of bacteria doubles. What type of function models the growth of bacteria on this counter? First of all, we know that the word doubles implies an exponential function, but just to show that, we're going to make a table. So at the beginning, you have 1 bacteria. 1 hour later, that doubles, so now you have 2. Another hour later, that doubles, now you're at 4. Another hour later, that doubles, now you're at 8. So we can figure out quickly that 2 divided by 1 gives you, that's a times 2. 4 divided by 2 and 8 divided by 4 all have the same multiplier of 2, so this is an exponential function. Whenever that constant multiplier is the same, it's an exponential function. And that is how you tell if a function is linear, if it has a constant adding and subtracting change, exponential if it has a constant multiplier, or neither if it doesn't have either of those.